Okay, so we're asked to evaluate this limit. We can't just think about substituting infinity because we'd have infinity over infinity. So we need to rewrite this a little bit algebraically. Okay, so let's see. They want us to use the quotient law. Okay, so they want us to rewrite this so that somehow we have 1 over x or 1 over x squared or something like that, because the limit of 1 over x would, as x goes to infinity, would be 0, right? If you take the limit as x goes to infinity, infinity of 1 over x, that's 0. Okay, let's see what they're asking us to do here. Well, this limit right here, as x approaches infinity, that's just what I said at the beginning, that this is infinity, so that we can't evaluate this limit right now. Since both limits do not exist as finite numbers, we cannot directly apply the quotient law. It's going to make me submit, and it's going to load for a while. I think it's easier for the student side because then you just see one question at a time. I think WebAssign right now is creating a ton of new versions of the same questions for me. Okay, so back to 16. Since we cannot directly apply the quotient law, so they want us to multiply the top and the bottom by something that'll help us apply the quotient law. Look, the highest power in the numerator is x squared. So if I multiply the entire top by 1 over x squared, I'm going to cancel out that highest power. And over here, I'm going to get 3 over x, and that's fine because the limit as x approaches infinity of 3 over x is 0. And I want to do the same thing on the bottom. I want to get rid of that highest power. That way, and I think they want us to rewrite it. Okay, that way I'll have 1 over x squared. No, I'll have 9 over x squared, which is easy to simplify. So 8x squared times 1 over x squared just makes, let's get my fraction, that makes 8. And then 1 over x squared times 3x makes 3 over x. Oops. That's the numerator. And the denominator, 9x squared times 1 over x squared makes 9. And then 9 times 1 over x squared makes 9 over x squared. And so that's what we're looking for, because now we can apply that quotient, the quotient law of limits. The limit as x approaches infinity now of the numerator is going to be 8. Limit as x approaches infinity of the denominator is 9. Okay, and then in step 3, there's our old step 2. Step 3, they want us to use the laws of limits. You don't have to evaluate this entire limit. You can make the limit approach 3 over limit as x approaches infinity over 3 over x here. So it's kind of like we're distributing that. Oh, they want it in negative exponent. I don't know why that's important. Oh, there's our 3, and this is x to the negative first. Can't factor that out of the limit because that's what we're trying to evaluate the limit of. And same over here. Limit as x approaches infinity of 9. Oh, we've got that. So they got the x to the negative second part here. What they're missing is the 9. 9 times the limit as x approaches infinity of x over negative to the negative second power. Okay, so the limit as x approaches infinity of x to the negative first, that's 0. Limit as x approaches infinity of x to the negative second, that's 0. So 0 times 3, 0 times 9, that just cancels out. We're just left with these constants, 8 over 9. They want decimals? They're not letting me type a fraction. Let me make sure. Because these terms are 0, so we're left with 8 over 9. Yep, they didn't want me to type a fraction. It's just weird they didn't have the fraction symbols.